Hi everybody, Quentin here from Modo. We are here with Ethical Power Connections. We've got Andreas and we've got Matt, and we're going to be talking about a hot topic in the energy storage world, which is connections, DNOs and all the good stuff around connection offers and how we get batteries connected and what we need to look out for. And this is probably, we're doing this with no prep, so who knows what's going to happen. And we met today at the Energy Storage Summit. We're going to figure out this whole thing in the next half an hour. So guys, who are you? Who's Ethical Power Connections and who are you two?
So I'm Andreas Fritzsche. I'm the Managing Director of Ethical Power Connections. We're an independent connection provider, but we're also a turnkey contractor, specifically operating in the battery energy storage market. So we would typically provide turnkey construction services for clients building out battery energy storage projects.
Yeah, and Matt Paterson, a lead on the business development side of things for the business, working with a number of developers to bring a project through from planning into construction.
Okay, cool. And we've been at a conference today, so if anyone can hear dry mouths from a lot of talking and networking, then please excuse us. Right, so you guys, you help people connect their battery assets, the battery projects to the grid, and you do that. Do you do the whole thing? So do you subcontract bits of it? Do you do the connection bit? Do you do the testing and commissioning? Do you do everything?
Yeah, so we can do everything. Obviously, with operating in a market sector which is focused on major projects and that being very peaky and trophy, we're never going to build everything and do everything all in-house, although we do have the capability to do the whole thing in-house, just depending upon how busy we are at any one time. We'll use our direct labour where we can, and that's from design all the way through to construction, commissioning, etc. And then depending on how busy we are, we've got a full supply chain of reliable contractors that we would use to assist us in those busy periods.
Okay.
We generally don't do civil construction in-house. We tend to, we manage the civil construction and we do the civil design, but we subcontract that out typically to local civil subcontractors.
So you don't do the concrete and those bits in the ground? Okay. All right, so I've got a battery, a hypothetical battery, the best battery in the world, it's the Modo battery, and we want to connect it to the grid. What do I need to do to connect a battery to the grid?
I suppose first of all you'd have to get a connection offer from a DNO or from National Grid.
Let's say a distribution connected to start with. So I've got my connection offer from Western Power Distribution, and I want to build my battery. And I've got, what do I do? Do I hand the connection offer over to you, and then you make it happen, or?
Within reason. I mean, there's a lot of work that we would do together with a client, but yeah, typically a client would approach us with a connection offer and a red line boundary, and maybe a conceptual layout of what their battery system would look like, and we would then work with a client to help them to understand what type of battery they wanted, how big their battery needed to be, how oversized it needed to be. What the important thing to understand from a client's perspective is we can play our part in specifying their battery, but it's very important that all of the other people play their part within the construction process or the development process to make sure that the battery that's been specified is the right size and is the right type of battery for their use case. And that's very, very important.
Okay, cool. So let's just get some hot topics out there. So on a connection offer, what do people building batteries need to consider or look out for? Where do the surprises turn up?
Constraints. So people can maybe not focus on constraints.
What does that mean? Does that mean the DNO turning you down, or?
Network reinforcement. So there can be constraints upon when they can connect. There can also be constraints upon
the time frame of the connection.
The time frame, also constraints on how much they can export. So certain periods in the year. So if there's a lot of solar connected in that area, then they might have constraints that mean in peak periods in the day in summertime that they're not allowed to export at all.
So when the sun's shining loads and all the solar's producing loads of power,
absolutely.
The DNO might say in a connection offer, so you can connect, but during the sunny periods, you can't export as much power. Is that what you mean?
Or maybe not export any power.
Okay, right. So so written into the connection offer, there's a few things that we need to look out for. So one of them so timings. How long does it take to connect? Right? Let's say I'm one of the DNOs. Let's use another one. We're going to get through all of them today. But let's say I'm Northern Power Grid and I make you a connection offer. Does that say we can connect in 6 weeks, 6 months, 6 years?
So there would typically be a date in there. I mean, it may be that you can bring that date forwards. This would all be done in liaison with the DNO. We would work with the client to understand what the feasibility was, how quickly we could bring it forwards. I mean, a lot of projects nowadays are kind of 132 kV connected. There's a lot more
So
at that
higher
higher
voltage.
voltage.
Yeah.
You know, procurement times are at least a year for your primary plant for those type of projects.
So higher voltage takes longer, is that right?
Yeah, procurement is definitely longer on a higher voltage.
Because you need bigger stuff, which takes longer to build.
Yeah, and
Okay.
so you know you can approach the DNO. There will always be a date in there, so your date will be detailed in your connection offer. You can then approach the DNO. It may be that there are no constraints in terms of network reinforcements, and in which case it may be that you can bring it forwards. But quite more often than not, there are network reinforcements of some kind that need to be done by the DNO. So it will definitely be a case of understanding what those network reinforcements are. And in some cases, there are things like big grid transformers that need to be replaced or have new tap changes installed on them, for example, which will mean that those lead times can get pushed out to longer periods of times, especially when transformer replacements are required. Those can take years.
Okay, right. That's yes, big transformers do take years, I guess. So just coming on a high level here. So if I understand this correctly, what we're saying is to connect a battery to the distribution network, say we want to do that at 33 kV or 11 kV, let's say 33 kV or 132. To me, as a connecting party, I'm the battery, that feels like I'm connected at the end of the sort of fingertip of this network, if you like. But actually, it's quite possible that the distribution network operator needs to upgrade other bits of the network further up the chain, further up, higher voltage perhaps,
Yep.
on transformers, tap changes, that kind of thing, so that I can connect at the end. And that means that when I get a connection offer, they might say, well, you can connect, but you're going to have to wait for me to do my bit further up the chain. Okay. Okay, that makes sense to me. So we've done connection offers. You get a piece of paper from the DNO that says you can connect, and it also includes. Okay, let's talk about contestable and non-contestable charges, because you have to pay for a connection, right? And it's split into two bits. Is that right?
Yeah.
And so how does that work?
So contestable is the work that an ICP contractor,
Sorry,
can carry
ICP?
out. Independent connection provider. So that's our type of business. Essentially, a contractor that has gained certain accreditations that mean that they can carry out works instead of a DNO to be able to connect you to the grid. And an ICP contractor can typically, not always do it more cost effectively, but they would normally be able to do it in a much better time frame, and they would also be prepared to sign up to contractual terms and conditions that a DNO would never be prepared to sign up to. So that can give a client more reassurance around things like timeframes and have an understanding that they're going to be penalties if those timeframes aren't hit, whereas a DNO would not be prepared to sign up to those types of terms and conditions.
So if I get this right, so there's non-contestable works. That's the bit that the DNO has to do themselves.
Yes.
And then there's contestable works, and what that means is the DNO says, you know what, you've got to do the work. Oh, someone's got to do the work. We're cool if you use this kind of company, ICP, and we're comfortable with them. They know what they're doing. They're safe on site. They've got the right, stripes, if you like, accreditations. So you can either wait for us to do it, or you can do it cheaper, better, or higher, with these guys. Is that how it works? And that's how an ICP has a role.
Yes. Yeah.
Okay, cool. And so we've done how much you pay for the connection. Broadly speaking, is there a number that people can use to say this is what it costs per megawatt to connect to the grid?
Not really. I would say that developers may use a rule of thumb in terms of grid costs. Mm-hmm. And there's a rule of thumb in terms, I would say, of if a cost is more than X, then that is a non-viable connection in terms of the developer's model for their project mm-hmm. or their type of project. But I would say that, costs can very much be variable depending upon how close the new project is to where the project is going to connect to the grid. So that's the thing that kind of...
Oh, yes, so
It's highly specific on location.
Yeah.
Because you've got to dig a trench and put a cable in, and maybe you've got to cross a road and get permission to do it, and all that stuff.
I would say that with a lot of projects these days are 132 kV, and a lot of projects tend to be developed very close to where they're going to connect to the grid, almost directly, quite often directly adjacent to it. And in that case, there is more of a formulaic number that you could say this is how much that type of a grid connection will cost at that voltage level, depending on whether it would be a looped connection or a teed connection. So you could say ignoring ground conditions, which will introduce more variability, but there is more of a formulaic cost of how much that size plant or type of plant would cost.
Okay. So we've done the piece of paper and the costs. So now we actually want to build this connection.
Yeah.
What bits of kit are there on a connection? Where's the money go? What are we paying for? If we pay an ICP like Ethical Power Connections, what do we get for that? Of course, it's a great deal, no doubt, right? But where does the money go?
Well, ultimately, from a primary plant perspective, you've got your power transformer, especially at 132 kV connection, and then you've got your switchgear that needs connecting into that.
Switchgear, which is big high voltage switches, right?
Yeah,
like light switches, but really big ones.
Yeah, invariably on a 132 kV connection, that would be connected at 132 down to 33 kV. It's 33 kV switchgear. That'll be procured on a long lead item.
Okay, so we need a big transformer. Yep. We need some switchgear, some circuit breakers in case things trip and whatnot.
Yep.
And then we need to connect on the 33 kV, the lower voltage side.
Yep.
And we need to connect some cables up and do some terminations and that kind of thing, right?
Yeah, and from a time frame perspective, that long lead item, which will invariably be the power transformer, that's going to make the project work in terms of a time frame perspective.
Okay.
So developers or any clients that are bringing projects through, that's going to be their first question is how quickly can you get a transformer on site? Okay.
And in case some people don't know, so just a transformer is the thing that changes voltage up or down from higher voltage to lower voltage, right?
Yep.
And it's a big, usually squarish thing with radiators on the outside, a colour green, or grey, and it's full of oil, and it just hums away. You'll notice these things are all over the place, but when you start looking for them.
When you start looking
for them. And that's a lot of the cost. That's the thing that takes a long time to build. And then the other stuff you guys can figure out with less lead time, right?
Yeah, typically that's the longest lead time item. There's a whole plethora of other equipment, but typically they're a lesser lead time. There's a whole bunch of measurement equipment, CTs, VTs, which is kind of a bit
current transformers and voltage transformers.
That's right,
yeah.
Current transformers, voltage transformers. That's how you can measure current and volts, and they're the things that you connect to all the sensitive relay equipment which control how the plant operates.
Just like your circuit board at home, right? Where
exactly
it will trip if
Absolutely.
you plug in I don't know. I don't know what I'm going to say. Yeah, a dodgy lawnmower. Right, okay. So now I'd really want to ask you guys about the type of connections. So from an investor perspective, what do I need to think about my connection? What's a worry to me, or what's an opportunity to me?
Well, a big thing that we try and help an investor to understand, if you're going to build a large-scale battery energy storage project, even if you've got a looped connection, which is classed as a firm connection, it's all of that power is typically going to flow through a single power transformer, so a 132 to 33 kV power transformer.
Big one somewhere.
Yeah, and what I would say is, that's a single point of failure, and a thing to really place value on, in our opinion as a business, is getting a power transformer from a reputable manufacturer that is going to last for the lifetime of the project. Because if one of those transformers fails, then that is going to take 6 months minimum, probably more like 8 months to get a replacement.
Ouch.
That's going to be painful for any asset owner.
So do some people do this? Do they have redundancy? Do you split it across two transformers?
Generally
share your
not.
risk?
So you would say that would be very sensible, and the way that a DNO would approach that problem would be exactly as you said, would be to build in redundancy and have a two transformers that were rated, what they call short-term rated, so that if one did fail, you could flow all of the energy through the other one for a period of time. But typically, investors wouldn't be. I think that models wouldn't stack up.
It's purely a cost issue.
Yeah. Okay.
We would love to put two in, but invariably that's not going to happen.
Because there's a lot of metal you've got to buy. I mean, am I right in thinking it used to be, this is really going back to my electrical knowledge here, but it used to be that transformers were priced on the London Metal Exchange or something like that?
Well, they still are. So, they're based on metals. So the cost of the transformer is generally based upon the manpower it takes to build it, but then also the cost of the metals that are within the transformer. So the variable price of a transformer is generally varied by the value of steel, copper, aluminium, all of the metals that are within the construction of the transformer.
And so what's happened there recently? Have we seen, because
Yes.
supply chains and commodities have gone through the roof, has this had a real impact on the cost of doing connections with transformers?
Cost-wise, yes. Costs across the board in the industry is a moving target almost daily. I would say the biggest risk really is going to be from a lead time perspective. It's going back to that where that's your biggest risk in terms of delivering a project on time. At the moment, we're seeing that nudge in terms of lead times. So we've got to make sure, as an industry, we're on top of that to understand and make sure people are aware that that's a real issue.
I mean, to give you an idea of how volatile it is at the moment, manufacturers are giving validity periods of their quotes of around 10 days.
Yeah.
Which is crazy.
You can't build a project like this.
And that's for two reasons. That's one, cost. Their commodity prices are changing just as ours are. And two, selecting factory slots within their factories across Europe and the world.
If COVID has slowed down factory slots, does that mean everyone's trying to struggle?
Factory slots before COVID were difficult. Factory slots during COVID got even more difficult, and now factory slots, given what the industry's doing, just crazily stupid.
We're going down a rabbit hole here, but that's the whole point. So they used to make transformers. There used to be brush transformers, right, in Nottingham by the
Loughborough, yeah.
Loughborough, sorry. And then who else makes transformers in the UK? Or do you buy them in from Europe or elsewhere? I don't know.
So we typically buy our transformers from Siemens. I mean, Matt's probably better to talk about this than I am.
Yeah, I spent time at Siemens, so got very aware. I've spent time in the factories and across Europe. Invariably, we use Siemens. We don't use Siemens across the board, but invariably we use Siemens. We see them as a grade 1 manufacturer, and again, in the main, we're looking at that lead time to make sure that's fixed for clients, etc.
Yeah, and with the volume of factories that Siemens have, they've been best able to deal with the strains that we're seeing in the market.
Yeah, I mean, when you talk about that factory loading, given that they've got their network of factories across Europe, it allows them potentially to move transformer orders from one factory to the next to allow to make sure your lead time's met.
They're not paying us to say this, but
No.
Yeah, I know. This podcast is sponsored by Siemens.
Yeah. No. Look, from our point of view, we'll never use one manufacturer because it just doesn't make absolute sense. But following our strategy of looking at grade 1 manufacturers, utilising Siemens on the majority of our sites, to us, is a strategy that's working at the moment. And I think it will continue to work going forward.
So when to clarify a point here, that there's lots of phrases that get banded around in our industry, and one of them is whether something is part of an EPC wrap or not. So whether, for example, you can go to, let's say, Tesla, or actually that's maybe a different example. Say you go to Fluence and you buy a big battery system, 100 megawatt battery system, and they give you an EPC wrap, and they say, I'm going to stand behind it, and if it, you've got one. You're the customer, I'm the vendor, and I will subcontract all the stuff out, and all the liquidated damages and that stuff goes through me. Yeah. Does the connection bit usually come as part of that, or is that separate?
It can do. I suppose you're going to go down the rabbit hole of then the contractual terms, blah blah blah. Most delays in terms of getting a grid connection would probably be caused by a third party that was outside of the control of the EPC contractor or us as a subcontractor that were delivering the grid connection aspect of the works. Typically, though, under an EPC contract, you would expect clients to attempt at least to get the grid connection contract put under the EPC contract. That's probably more familiar in solar, and probably I'd say less familiar in battery energy storage. They're quite often delivered as a separate, separate contract.
Okay. Can I ask you about battery energy storage connections compared to other generation assets? So how is a battery asset?
Interesting subject.
So say, let's compare a 40 megawatt, let's say the same numbers. So let's say a 50 megawatt gas peaking plant versus a 50 megawatt battery. What's different on the connection side?
So mainly your input capacity. On a solar project or on a gas peaking project, a gas peaking project would have more of an import requirement. than a solar project. A solar project would have quite a minimal import requirement, and then a full export requirement, whereas a battery energy storage project would need to have an equal import and export requirement because
You need to charge and discharge.
charge and discharge.
So does that mean you have to size equipment to do swings from 100% out to 100% in? Does that mean that you're doubling the size of certain equipment from the DNO's perspective? Or is that maths wrong?
No, I don't think so. Again, I'm not an engineer, so this is a question that I would ask one of my engineers to answer. But no, typically, I don't think you would need to double the size of anything because it's still energy that is just flowing in one direction or another. But you are right. You need to ensure that your power transformer, for example, can handle a swing from a full 50 megawatt import to a full 50 megawatt export, because that could well happen.
Yeah. Okay. And what else is different? Let's talk about G59 or G99 or whatever number it is now. This is what I think, and you're going to tell me I'm well out of date. But it used to be that you applied, you filled out your form to the Electricity Network Association. You did it was like a G59 form, it was called. You got your connection offer. You connected to the DNO, and then you scheduled a time where the DNO, a commissioning engineer, would come and witness the site being energized. You'd do some tests and then you'd be on the grid. Now there's a new process, which is G99, so that just the numbers change, but the letters are the same. What's different, and what does everybody need to think about if they're going to be connecting assets?
This is a good question, actually. The thing that's different, I would say, in G59, that was a very small number of commissioning tests that could be done quite quickly and quite easily in one day. Say on the connection day, the energization day, you could have your project connected and energized, and you could then also have your G59 tests carried out the same day, and you could then be exporting to the grid.
These are tests to make sure that your asset won't disturb the grid, and also that it's safe, and then it will, and all that kind of stuff. But it's the DNO who's responsible for those bits, isn't it?
Essentially, frequency deviations, and it kind of protects both the grid and the generator. If either of those are performing outside of the set parameters, the G59 relay would essentially disconnect those two things from each other to make sure that both the generator was protected and the grid was protected. But with and again, I'm not an engineer and I don't understand these things that deep, but what people have realised is that with all of the large generators going offline, they were the things that were helping the grid when the grid was under fault situations. And with the grid becoming more and more reliant upon renewables, that means that they need to be able to rely on renewable projects, renewable generators to assist the grid in times of stress. And so, whereas under G59, that would very quickly disconnect the generator from the grid, under G99, they generally want the generator to stay connected to the grid and to assist the grid when the grid was strained under fault conditions. And under G99, they now stay connected to the grid for longer and try and help the grid, and it's only after a certain longer period of time that they would then disconnect. So that's one of the big things around the differences between G99 and G59.
So you can stay connected a little bit longer in an event. Is that how I understand?
Yeah.
Okay. All right, I want to get to hot potatoes. Right, what do you guys? You're in the office and you're chatting about connection stuff. What are the hot potatoes, whether it's changes in rules, standards, commercial terms, expectations, customers, DNOs? What's kicking around at the moment which could change things?
Demand.
Okay.
Ultimately demand and what's going to be connected on the grid over the next 24 months.
Do you mean, does that mean there's a lot of demand or not enough demand?
A lot of demand.
So lots of people want to get connected and perhaps more people than can in that time? Or
Yeah, I mean, I think that Matt's entirely right. There's a very high demand now. I think that when we look at the show that we're all attending today, it's a lot different, the world to the world. Even a year ago, you would say that battery energy storage was, stagnating maybe a year to 18 months ago, and the excitement and interest in battery energy storage today is monumentally different.
I mean, the drift in what we've seen of what we're connecting currently and what we will be connecting in the next 24 months has gone from battery energy storage 18 months, 24 months ago, 25% of our business to 75% of our business at this stage.
So you're the battery connections guys now?
Yeah.
One of them.
I mean, sorry, that's you're the,
Yeah, but it's becoming a more important sector for our business.
Yeah.
And I think that any business that is doing the same type of business as us, we're not special within that. I think that all of our competitors will be seeing the same level of increase in activity. And I definitely think there's probably going to be a supply chain issues in terms of the number of contractors that are available and able to carry out these type of works, and the number of clients that are wanting those services. I definitely think there's going to be supply chain issues. You know, you can see that there's supply chain issues from a manufacturer perspective, and prices are increasing. I think you're going to see similar things within the actual contractor supply chain. You're going to have similar constraints.
No, it's kind of funny because you hear a lot about people talking about cell costs increasing. So, panic, cell costs are increasing 15-20%. That's and maybe the balance of plant is increasing a bit. But the connection bit always feels like a bit of an afterthought. And yeah, if the prices are increasing there too, that's across the board. We're looking at big
wholesale price increases.
Yeah.
I mean, the volatility within the sector is we've got the same issues with commodity prices.
I mean, that is the ultimate hot potato, isn't it? The commodity prices and the raw material prices.
Yeah. Like prices are going up exponentially, and they're going up month on month. You think that you're seeing the ceiling of price increases, and they go up again. And it's difficult for a contractor like us to put a pin in what the price should be, because as we've talked about, projects that we win today are going to be delivered over the next 12 months. So we're not going to realise some of those costs until 6-9 months into the project. And if those prices have changed, that's a big risk to a business like us. So that would be, I would say, the biggest hot potato for us as a contracting business is how do we protect ourselves from those risks in terms of the volatility of the marketplace. And one of the big things we're looking at doing is, at the point we're signing contracts, is saying how can we fix our risks by paying for things today and securing that cost price. It may be that we pay a high price today and the price goes down over the next 9 months.
But you can hedge.
But at least you know that you're not going to see prices
it's a calculated risk rather than a risk that you don't know is coming.
That is our big hot potato, I would say, is commodity prices and price fluctuations.
Okay, I've got one last question for you, and from people who are in the industry, you guys are in the industry, you're in the thick of it, you know how connections providers work and think. What do developers and asset constructors, builders, banks, financiers, people who are involved in getting these assets built, how do they choose an ICP?
I think a lot of people choose to, I think they run a process. I think a lot of people would go through a process where they would try and understand pricing, albeit that's conceptual pricing, because if projects are getting built in a year, 2 years' time, pricing is going to change.
Do you need apples with apples comparisons?
Yeah, and I think a lot of these things are relationships that are built over time. A lot of clients, they're not building one project, they're building a pipeline of projects, and they need and want to find a contractor that they can rely on, that they can build a working relationship with. And I definitely think there's been a maturing in the marketplace where clients aren't necessarily looking at it as a one-time thing. They're looking at it as a long-term strategy. We're definitely seeing that's what's happening, where they do they work in the way that we want to? Is there a good relationship? Yeah, good openness. It's just about synergies between one business and another business, and if those two businesses align the way that they think align, then I think that's how things happen.
Okay. I'm going to open the floor. Is there anything that you want to discuss now is there anything that I've missed that we should make sure people hear?
I'm not sure.
I think we've covered everything. I mean, in terms of how we connect and how we wish to connect going forwards, and the potential hot potatoes, I think we've covered most of the points.
Yeah, I think so.
So I'm assuming if people want to follow you guys and connect with you as connection people, that wasn't intended. No, it really was not intended. So they can do. I assume they go on your website and they can contact you. We'll put a link in the comments and they can.
Yeah, we've got a LinkedIn presence.
Yeah.
Matt runs that for us, so we've got our own LinkedIn page for the business. We're all as individuals on LinkedIn, and we're very active on LinkedIn in terms of the community, of the sector. You know, we're very much up for engaging with other businesses that are within the sector that are interested in talking about the kind of things that we've talked about today.
Brilliant. Okay, so I just want to say, guys, thanks for coming on. This is completely last minute. We did it without any planning.
Well, I think we met in a lift last night.
We met in a lift last night, and we ended up in this hotel room. I just want to say thanks for coming on. It's been awesome, and
thanks for having us.
we're looking forward to seeing you guys have a big impact in the future.
All right,
Thanks very much. Cheers.
Cheers.
Thanks very much.